Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and as always, I'm here with Victor. Before we dive in, I want to remind our listeners that your feedback means the world to us. If you're enjoying the show, please take a moment to rate us on your favorite podcast platform. Now, let's get started.
Thanks, Sheila. Today we're continuing our journey through Chapter 2, Fundamentals of P2P Networks. For our new listeners, P2P stands for peer-to-peer, which are networks where all participants, or peers, have equal status and can directly interact with each other. We've already covered the overview of P2P systems and network topologies. Now, we're diving into the challenges that P2P networks face.
Absolutely, Victor. And to kick things off, I've got a quiz question for our listeners. Here it is. What common networking issue often affects P2P systems, making it difficult for peers behind home routers to connect directly to each other?
Ooh, that's a great question, Sheila. It touches on a fundamental challenge that many P2P developers encounter. I'm curious to see if our listeners can figure it out. It's something that doesn't usually affect traditional client-server applications, but becomes a real headache in the P2P world.
Exactly, Victor. Now, before we dive deeper, let's make sure our listeners are on the same page. Victor, could you give us a quick definition of what we mean by challenges in the context of P2P networks?
Certainly. In P2P networks, challenges refer to the obstacles or difficulties that arise due to the decentralized nature of these systems. Unlike centralized systems with a clear hierarchy, P2P networks face unique issues because of their distributed structure and the equal status of all nodes.
That makes sense. So, let's start with one of the most basic challenges. I've heard that scalability can be a significant issue in P2P networks. Can you explain why that is?
Absolutely, Sheila. Scalability is indeed a major challenge in P2P networks. As the network grows, the number of connections between peers increases exponentially. This can lead to what we call network congestion. Imagine a room full of people where everyone is trying to talk to everyone else at the same time. It quickly becomes chaotic.
That's a great analogy, Victor. So, how do P2P networks typically handle this scalability issue?
There are several strategies, Sheila. One common approach is to use what we call super peers or ultra peers. These are nodes with higher bandwidth and processing power that can handle more connections. Think of them as the extroverts at a party who can chat with multiple people at once. Another method is to implement efficient routing algorithms that reduce the number of hops a message needs to take to reach its destination.
Interesting. Now, moving on to a slightly more complex issue, I've read about something called network churn. What exactly is that, and why is it a problem for P2P networks?
Great question. Network churn refers to the constant joining and leaving of peers in a P2P network. It's like having a party where guests are constantly arriving and leaving. This creates several challenges. Point 1. Maintaining an up-to-date list of active peers becomes difficult. Point 2. Data stored on leaving peers may become unavailable. 3. The network structure needs to be constantly reorganized. This churn can significantly impact the stability and performance of the P2P system.
That sounds pretty challenging. How do P2P systems typically deal with network churn?
There are several strategies, Sheila. Point 1. Replication, storing multiple copies of data across different peers. Point 2. Caching, temporarily storing frequently accessed data on multiple peers. Point 3. Predictive algorithms, trying to anticipate which peers are likely to stay online longer. 4. Incentive mechanisms, rewarding peers for staying online and contributing resources.
Those are some clever solutions. Now, let's touch on a more advanced topic. I've heard that something called NAT traversal is a significant challenge in P2P networks. Can you explain what that is?
Absolutely, and this ties back to our quiz question. NAT, or Network Address Translation, is a technique used by routers to allow multiple devices on a local network to share a single public IP address. While this is great for conserving IP addresses, it creates a problem for P2P networks. When a peer is behind a NAT, it can't receive incoming connections directly from other peers on the internet. This is because the NAT doesn't know which internal device should receive the incoming connection. It's like having a receptionist who doesn't know how to route incoming calls to the right person.
Ah, I see. So how do P2P applications overcome this NAT traversal problem?
There are several techniques, Sheila. Point 1. Stun, Session Traversal Utilities for NAT. This helps a peer discover its public IP address and the type of NAT it's behind. It's like finding out your own phone number and what kind of phone system you're using. 2. Turn, Traversal using relays around NAT. This uses a relay server to forward traffic when direct connection is impossible. Imagine having a mutual friend pass messages between you and someone you can't call directly. 3. ICE, Interactive Connectivity Establishment. This is a framework that tries various techniques to establish the best possible connection between peers. It's like trying different methods to reach someone until you find one that works. These technologies work together to help peers connect despite NAT barriers.
Fascinating. It's amazing how many layers of complexity there are in P2P networks. Before we wrap up, could you share a fun fact or anecdote related to P2P challenges?
Sure thing. Here's an interesting tidbit. The concept of NAT traversal in P2P networks led to the development of the hole punching technique. It's called this because it essentially punches a hole through the NAT firewall to allow direct communication. When it was first introduced, many security experts were skeptical, thinking it would create vulnerabilities. However, it's now a widely accepted and secure method for P2P communication.
That's really cool, Victor. Now let's reveal the answer to our quiz question. The networking issue we were referring to, which makes it difficult for peers behind home routers to connect directly, is indeed NAT, Network Address Translation.
Exactly right, Sheila. And as we discussed, NAT traversal is a crucial challenge that P2P developers need to overcome.
To summarize today's episode, point 1. P2P networks face unique challenges due to their decentralized nature. Point 2. Scalability is a major issue, often addressed through super peers and efficient routing. 3. Network churn creates instability, mitigated by replication and caching. Point 4. NAT traversal is a significant technical hurdle, overcome by techniques like stun, turn, and ICE. Remember, understanding these challenges is crucial for designing robust P2P applications.
Absolutely, Sheila. And to our listeners, we hope you found this deep dive into P2P challenges informative. If you did, please consider supporting us by visiting crashcasts.com, joining our Discord community, or even supporting us on Patreon. Your engagement helps us create more content like this.
That's right, Victor. And don't forget to subscribe to the podcast and rate us on your favorite platform. Until next time, happy coding, everyone.